How is everybody doing today? We are gonna be making some cool stuff. While we're gonna wait a few minutes, let some people get in, let's hang out. Little crab rave, because I know I will get chastised if I don't play it. Bit of a, it's not a spoiler, but warning. Oh, warning's probably the right answer, or thing to say. It is storming outside, so if the stream randomly dies, it's because I lost power. But it's Florida, so that's just the way it goes sometimes. Put the stunt double here, because Victoria is off doing important cat things. We're gonna be making some cool stuff. We'll hang out for a few minutes, let some people get in here. Yeah, it's gonna be weird. This is one of those products that I just came up with the staff, and we're like, this is just dumb enough that it's a good idea. Because it's going to involve a lot of things that I just don't know how to do. And I'm kind of excited to learn that with you guys. So I think it's gonna be a bit of fun, but I'll turn Crab Rave back up for a little bit. We'll wait for people to get in here, and we'll get this bad girl moving. Hey, Allison, how you doing? All right, I am doing good, Allison. I am doing good. It's been a week, but I'm here. I know we had some interesting news yesterday. I'm both bummed and very happy. We have one of our team members is going to be leaving us, but they're going to an amazing opportunity. So like, as a business owner, I'm so sad to see them go, because I was, they weren't with us for very long, but it was, I wish we would have more time, but I'm so glad that they have an amazing opportunity that, yeah, I don't blame them for taking either. I'm doing good, though. Yeah, it's been a fun week. Florida's just deciding it's going to be a lot like the UK, and it's just been rainy and crappy all week. I don't leave the house much, so it's really not a big deal to me, but I can hear the rain outside, and I can hear the thunder, so... Yeah, if we lose internet and the stream goes down, sorry, I can't control it. Oh, man. Alright, let's dive into this. Hey, Nadav, how you doing, buddy? I will say, the one thing I still don't like about this back injury is how little I can sleep. I think I got the most amount of sleep I've had, well, minus CT myelogram, because that put me out for a few days, but most amount of sleep I've had since then, and I got 3 hours. 3 hours of sleep. Yeah, you work with what you got. But today, we are going to be working on some cool stuff. If you saw the title of this video, you might have a bit of an idea of what we're doing. If you didn't see the title of the video, you have not a damn clue what we're doing. We're going to be using one of these. This is a 30 caliber ammo can. It is plastic. They're cheap like borscht. And we're going to be putting a bunch of these inside of it. These are... Let me pull the thing off of it here. This is a DJI Osmo Pocket. And if you guys are watching the videos of the standing set, so the newer videos, like there's one coming out at 2 p.m. today, where the front-facing camera, the one that is like, pointed directly at me, that is filmed on these things. So we're going to be switching over to these as our main cameras. The only issue is we can't stream with them. Unlike these camcorders, like the Vixia HF R800 that I'm filming with, this doesn't have clean HDMI out. It actually only has USB-C out, and we cannot pull a video feed from that. We've tried. Currently, what we're doing to try to be able to stream with these is emulate Android inside of Windows, but the DJI app requires Bluetooth. So now we're looking for an emulator that can enable Bluetooth, even though these things connect over Wi-Fi. So I don't know. I don't really know how it's going to work. We're going to give it a shot. If we can't stream with them, we can't stream with them. I am going to be trying to get better streaming cameras so that we can do more streaming out there. But it's funny, it's the exact same camera, but it's much farther away. So I think it's just grainy. You just don't notice it here because of how close I am. My computer will not support Windows 11, Justin. And I'm not certain the streaming computer will either. I have a 4770K, which is not supported by Windows 11, which I laugh at because it's still a perfectly acceptable computer, we will say. But I don't know if Windows 11 will support it. But yeah, I'm going to talk through this project real quick with you guys, and then we're just going to jump right into it. And I want to thank Justin, because Justin's going to be my right-hand man on this, and eventually Alan will be as well, because we're going to do some custom circuit boards, because what could go wrong there, Grant? Oh, cool. Windows 11 has native Android emulation. That's interesting. Anyways, we have 7700 on the streaming PC, so that's, it's funny, because the streaming PC actually has a better processor than my computer. Anyways. Alright, so here's the basis of this project. We've got our ammo can, okay? They're pretty big. It actually fits an Osmo Pocket in with room to spare. We have 4 of these cameras. My brother has 1. So we have 5 in this house total. So I want to build a container that can hold 6 to 8 of them minimum. We're going to allow them to charge, so when they go into the container, okay, they're going to have to slot into a USB-C connector that will then be wired into an XT60 connector so that we can use a USB cable, we can use a power supply, whatever we want to power these things. And it's also going to have a USB splitter on it. That way we can power other devices, whether it's, you know, to charge up battery banks, cell phones, whatever. We want this to be a portable charging station. I don't want to put any lithium in this. Like, I don't want to put any, like, big lithium batteries in it. Because I'm putting, like, these cameras are $250 brand new. You can get them for, like, $140 on eBay. I don't think I paid more than $140 for any of these. But we're going to be putting, like, retail over $1,000 of cameras in this. And I don't want to put lithium. And I recognize lithium's gotten a lot safer. But we're going to do that on the next iteration. We already have this one figured out. Like, we know what we want to do. And so we've already started working on iteration 2. This is more for around the shop, where I'm just going from my computer to the garage sets, so I can keep the cameras all organized. We're going to use a Pelican case, or a generic Pelican case, as version 2, that's going to hold all of the cameras, all of the accessories, because these Osmo Pockets, as a main camera, don't do a ton. You need a joystick module if you want to be able to move the gimbal without using the touchscreen. There's Wi-Fi modules if you want Wi-Fi. They've got these little charging cases. And they've got tons of other accessories like housings that hold them down to GoPro mounts and quarter 20. Lots of accessories that we want to be able to store in here if we can. It's not going to be a huge thing if we can't. The big thing about this is to be able to put them, just slot them all in and get them charging, right? The goal for this is to build some sort of a mass charging case. So it is going to require us to use a vertical USB-C connector, a custom PCB with pinouts. So yes, this is actually going to include soldering and a lot of other things, but this is going to be a multi-live stream series. This is not going to happen in one stream. It's not how it's going to go. We're going to be doing this over a few weeks. Ah, that's awesome. A 7700 will not work with Windows 11, so none of the computers in my house, except Amber's computer, funny, Amber has the strongest computer in the house, but will work with Windows 11. Well, maybe we'll be able to hack in Windows 11, who knows. I don't want to deal with that kind of stuff right now. But yeah, the first thing we got to do is actually reverse engineer this container. This container is patented. However, when I pulled the patent for it, I didn't find anything of value, if that makes sense. I can show you guys the patent, but instead, I'm just going to put the patent in the chat so you guys can have the patent there in the YouTube chat. So if you're watching us on a different platform, head over to our YouTube channel and watch us there. But yeah, this thing is actually patented, but it's design patent, so it doesn't give us any of the sizing that we need. And sizing is kind of the big deal because, like any can I take the lid off of this? Oh, I can. Sweet. All right, I'm gonna pull the lid off because it's gonna make life a whole lot easier. All right, the lid is off. Will make moving this thing around so much easier. The design patent does not give us dimensions, and like any what am I going with here? Like any injection molded product, this is clearly injection molded. It is drafted, so there is a slight angle. And all right, we're gonna peel this. We're gonna do this right on the stream here. I'm gonna do the peel for him to get it closer to the microphone too. All right, peel. The peel is done. Okay, it is drafted. That means that the top opening is bigger than the bottom. So we have to figure out what all of those sizes are. And that's going to be the primary focus of this stream, is we're going to be reverse engineering this ammo can. Because I can buy these locally. They're like $5. We have linked some in the description as well as the cameras and all the accessories that we're going to try to put in there. The goal for us is to make a portable station that we can take with us. It will need to be powered, but it can charge all the cameras at once. It's going to have holders for batteries, just stuff. And if we've got the room, we're going to use, our main recording microphone is a Tascam DR05, and the lav mic that you all see me wear goes to a Tascam DR10L. And if I can fit these in there, I will, but it's not a huge deal if we can't. They will fit in version 2, they may not fit in version 1. So we're going to start by reverse engineering everything. I will show you guys, let me switch over to Small Grant. This is the patent, and patents can be kind of boring, and there's not much to this, right? We've got the individual figures, and this is what it looks like, absolutely, but we don't know the scale that these are drawn to or anything like that, so unfortunately we can't really use this as much as I might want. So a bit of a bummer there, but that's okay. We can see that they're citing other patents as well. So realistically, this is of no use to us. It's a design patent, and if you're curious, it expires January 9th of 2033, or I think that's right. It's January 9th, or it could be September 1st. So, is that right? Yeah, September 1st. So yeah, it's just a design patent. So we're going to reverse engineer this thing. So we need Fusion 360 for that. So let's get into it. Have our handy dandy calipers, and let's just get on it, because what we need to do is we need to measure the exterior dimension up here and then attempt to measure roughly at the same place what the interior dimension is. That will let us know the thickness of the plastic. Once we know the thickness of the plastic, all we really need to do is take the outside measurements and everything else lines up. Make sense? Cool. Now, I'm gonna take a basic assumption here. We see that the bottom is inset a little bit. I would guess that the thickness of this... Oh, it is also chamfered. Dang! So the bottom is also drafted and chamfered, but it's drafted and chamfered quite a bit. Alright, we're gonna do it the hard way. So here's the container. I'm going to just take a measurement from the outside here, right underneath this lip. So right underneath the lip, I'm gonna take a measurement. I'm in inches. Why I'm in inches, I have no freaking clue. I must have hit it. Let's see here. 113.2. And somebody is messaging me on Hangouts. Give me just a second. Oh, wait, I can check out from my phone. Dang it, Jonathan. All right. Let's do it. So we know, let's get a basic drawing done here. We're gonna do this all from the top. It'll just be easier for me. We're gonna start with a center rectangle. So we have our short side. Our short side is 113.19. Okay, 113.19. Okay, we don't know what our long side is, but it's too long for me to check. Oh, actually, it's not. I have my 12-inch caliper. Let me grab my 12-inch caliper. It's a little bit out of reach. Come on, that's a good stretch, though. Come on. You guys saw this in the last, in the tools video, my 12-inch caliper. See, sometimes you need a little bit bigger than what you got, gentlemen. You know what I'm talking about. See, nobody's here to edit out my bad jokes. I am uncensored. Live in the flesh! I hate the damn battery cover falls into an area that's really tough to get into. Alright, big caliper, big case goes away. Alright, big freaking calipers of science. Look at that. Big freaking calipers of science. We're going to measure it basically the same point for the length here. We can probably just do the rest with these. I don't really think we need to use any other calipers than these. Is this all done in inches? No. $249 on the money. That's interesting. Alright, so we need to dimension it out. D for dimension. We'll dimension this out. It's $249 on the money. So there we go. We've got kind of our basic exterior shell. Now we need to do this for the interior shell. Now again, I cannot measure directly at the top of this box. I'm measuring kind of right, along this edge. So when we measure on the inside, we have to basically measure at the same locations. And because this thing is reasonably translucent, I can cheat and use the shadow and my lighting to figure out where everything lines up. God, it's a big part. Alright. You guys, if it wasn't clear, I might not be able to print this in one piece, but we might be able to. That'd be kind of cool if we can. Okay, I think it's 244.5. I need to do it off camera so I can actually, hold it decently straight. No, it's 245. Interesting. It's 245. I have no place to put the big freaking caliper. Jeez. All right. I'm gonna bet that it's the same 5mm thickness. That can't be right. That's really thick. I'll do another center rectangle. We know that it's 245 there by, let's get the interior dimension for this side. It's to be about 109.25. So is that an accurate 5mm between them? No, that's 2. Alright, it's 2mm thick. I mean, that's... I get 2 and 1.97. It's 2mm thick. And I'll take that to my grave. Because what we're actually going to do is not worry. We need to get the thickness so we can figure out the drafting and all of that. Because ultimately, this bottom piece is not going to be a tight fit. I don't want it to be a tight fit. I want it to have a little bit of wiggle room. Because what we're going to do is we're going to put some JB Weld or something on the bottom of it. Or some sort of maybe hot glue. Something that takes a while to set. And we're going to put all the cameras in, and that way the thing lines up to the cameras, and then we leave everything in to set. Or I might just put some screws in the bottom of it. I don't know yet. Screws in the bottom might be a little bit tough to align everything. And I would also potentially just invalidate the waterproofness, because this thing actually has a gasket seal, and it is waterproof. The hope is that we can keep the weatherproofing, waterproofing, whatever, still intact on this. So that is awesome. We're going to actually get rid of that. We're going to do an offset here, and we're going to flip it, and it's going to be a 2mm thick. When we had one that was 1.97, one that was 2 on the money, it's 2, right? When you do this type of design work, most people aren't going through a ton of effort and work and all of that to try to make it precise enough. It's going to be 2. You know, they're not going to bother. I just want to make sure the music isn't too loud and it's not too quiet. That's probably fine. Let me get a little bit of water. And then we're going to do the measurements for the outside of the bottom. Now, something to note. I said it before. It does not have a flat bottom. It's got a lip. Okay, so it's got that lip. I don't know if you can easily see it because the orange is rough on the camera. But we're going to measure the depth from the top down, from this top surface, all the way down. And that's going to tell us how far down it is. We just have to basically, again, use the shadow, which I can see, you can't see. But we use the shadows to kind of tell us where everything is. And no, not Raid, Shadow Legends. Would you all hate me if we accepted a sponsorship from them? I might hate myself, but I don't know. Maybe we do it as a meme. No, they have not reached out to us. Although that would mean we have hit peak YouTuber if we get Raid Shadow Legends. About 103? Do you get wider as you go through? You totally do. Well, that's another problem. It bows. How much does it bow? This is not dead flat. That is so interesting. That might have just been because of the mold is not flat, so we're going to measure it at its shortest area, which is, you know, right about yonder. 103.5. So let me... I'm going to finish this sketch. I need to do an offset from here. It needs to be a negative number, so let me do the offset. Now, to measure a depth, you can actually use a little thing that sticks out of the bottom of your calipers. The depth is 149.7. Is it really 149.7? It's not 150, seriously. It is 150, okay. Alright, so it's going to be negative 150. We're going to do another sketch down here. And we're going to also do, again, a center rectangle. We know that this dimension is 130.5, I believe. Was that good measurements? Okay. See ya, Allison. Thanks for hanging out. Appreciate you hanging out a little bit. We're still trying to get these streams in a time that works for everybody. No, it was 103. 103, not 130. Yep, 103.5. 103.5. The other dimension is... Sorry, guys. I gotta get a top-down camera for my desk. The problem is my desk is so crazy, and there's a lot of stuff on here I can't show on camera. So you all will just have to, unfortunately, bear with me for a little bit. Alright, looks like the outside's about 239 on the bottom. Okay. And that's all exterior. So again, we can make a basic assumption that it is a 2mm thickness. So we'll hit 2. Beautiful. We're going to finish this sketch because we got to actually build our box first. So now we're going to create a probably a loft between here and here. course, it's gonna do it that way. That's fine. We've now created our body. We're gonna go back, bring up our sketches. We're gonna create another loft, which is gonna be from here to here, and it should cut it away. There we go. We're left with that. We're going to grab an extrude on here. We're going to extrude 2 millimeters because that's the base, your bottom. Now, it is filleted. I should have printed out a set of fillet gauges because I don't have a set of fillet gauges, which sucks. I think we can put these away for now. So I'm going to put these kind of down and away for me. But I don't have a set of fillet gauges. The thing is filleted. But we can worry about the filleting later. I'll just keep it away from the edge. My guess, I could probably fillet it by eye. Or actually, let me see. Let me find. I'm going to go onto the net. You guys can come with me. Let's see how to measure a fillet. How's a fillet measured? A radius gauge. Well, I don't have a radius gauge. Ah, of course it's Reddit. Oop, hold on. Ah, whatever. Let's see. Alright, I have my own way of doing it. It's the same way I've done it for years. I come in here and I actually measure where the radius starts and stops. I'd call this a 3mm fillet all day long. And the fillets are kind of necessary for us. We don't care about them on the outside, so I'll probably just leave the outside the way that it is. I believe these are 3mm fillets. Yeah, I'd say that's fine. And it's going to bother me, so I will put them on the outside too. I said I wasn't going to care about it, but I definitely lied. I do care. The product is 2mm thick, so we can go to a 5mm fillet, and it should be an even fillet all the way around. And that's a great tip if you guys are trying to do fillets on something that has some thickness to it. The distance of your thickness is what you add to your fillet, and it will keep a consistent thickness for your extrusion. I think that it is 3mm. We'll see. I'm going to assume that if my fillet is a little bit tighter than theirs, it might not fit perfectly, so we will probably end up printing a set of radius gauges, which I'm sure if we go to Prusa printers, we can find some. Okay. All right, let's see what we got for radius gauges, because you know what? I got bright pink in the machine. I'll run some radius gauges while we are while we're working. Let's look for fillet gauge, because maybe by the end of the live stream I can have the part done and we can take a look at it. So let's see what this one looks like. How many do you have? Oh, cool. These are like a whole thing. So you have 10, 14, 8, 6, 2, 4, 12. Literally the one that I think it is missing. Hilarious. Let's look for one more. I'm not a huge fan of the ones that are multiples. I prefer individual ones because they're easier to measure with. Let's look at this one again, this radius gauge. Bro, that's a lot. All right, forget it. I don't know which ones I want. We'll do it later. Hashtag later. All right, so we got our bottom. The bottom is also going to have a fillet. It has a very small fillet. All right, let me do another small fillet. If anything, it's like a 1mm fillet. Yeah, honestly, that's pretty much on par. We'll take that. Because the part that we want needs to fit in, right? Needs to fit in. And we want it to be the entire length of the case. So now we got our boxes done. Okay. We have to do the Osmo. The Osmo is tough, and to show you guys why it's tough, I'm going to use one of its cases. I'm going to go to Big Grant here real quick. If we look, you see how it's got this curve on it? Yeah. I'm not happy about this. So we're going to do this in a very unique way, or maybe it's unique, maybe it's not. I don't really care. I think it's unique. Or the way that I've done it. Now, if you have a flatbed scanner, which I do, it's not hooked up right now. You could actually just scan this and take a drawing from it. I am actually going to hold it up to my computer screen. And if I'm smart enough and I draw it in full scale, and it is full scale on my computer screen, I should be able to draw my my actual template for it. So we've got that part. This is our box. Now, why do I have two bodies? Oh, did I make that a new body? No, I want to join. Oh, I bet I know what happened here. Let me check something. Yeah, that fillet does not like this. Why do you not like this? All right, we're gonna roll back to this fillet. We're going to delete it. Gonna redo that fillet, and I'm betting. Let me check before we redo the fillet. I have a feeling our section analysis is going to show us a problem here. Yep, there's your problem. It doesn't touch. So when we do this extrude up, we have to do a taper angle. So we're gonna have our taper angle be 2 degrees. Will that work? I don't know which way you're tapering. Damn it. Turn off the body. Let me just do to like 10. Whoops. 2 millimeters there. Let me do 10 degrees. Okay. So yes, that is the direction we want to taper it. Actually, 10 degrees should be fine. And we want it to join. Now, if we bring up our section analysis, which is not here anymore. Whoops. Let's do another section analysis. We'll just cut it in half. It'll be easier for us to look at it. We look at our section analysis. Everything is one piece. Beautiful. So we can come back. We can get rid of our section analysis. We can come back and do our fillet. And so this is what happens when you deal with drafted parts. Oh, Grant, you're not showing anybody anything, you ding-dong. Oh, all right. Well, guess I got to roll that stuff back. Let me show you guys what was going on here. All right. Well, that sucks. Let's just redo that. See, if this was an edited video, I could just go, and it would be fixed. Oh, well, we will do inspect section analysis one more time. Now you guys can see what's actually going on here. You can see that the parts don't line up. So there's a gap. And then the gap is from here to there. And that is because of the draft angle. So what we want to do is we want to go to our extrude, and we want to add a taper angle. 10 degrees did work last time, so I'm just going to reuse it. And now that I bet that fillet is totally fine again. Yep, it's fine again. There you go. See, my mistake ended up actually making it faster at the end of the day. So I think ultimately you guys won. All right, so we have body 1 here. We're going to go ahead and turn it off because we need to do another sketch. All right, we need to get so we're going to do just a rectangle. So we're going to assume that the body down here is totally flat. And then we will go ahead and do the curve later. So we need to go ahead and make that. So make sure my caliper is zeroed. 29.22. So again, we're going to grab a rectangle. It's going to be a center rectangle. The width of it is 29.22. Now, because I want to give these a little bit of room, we're just going to go straight. No, Grant, do it to the right size. Yeah, we'll do it to the right size. And I am going to measure from... in here. It gives me 20 millimeters exactly. Now, there is still a curve. Is this really going to be, like... Yeah, it totally is. I was checking to make sure this thing wasn't going to be, like, you know, tapered or something. I'm actually getting 29.35, I think. Yeah, 29.35 makes me feel better. It's a little bit too big. It's a little bit too big. Now we got to deal with our arc. So we're going to do an arc. It's going to be a 3-point arc here. Something like that. Okay. I'm going to X out of that. I'm going to go straight on the top of this. And I'm going to zoom it out until it fits. Oh, it's so tiny. Oh, damn. Did I get this right on the first friggin' try? No, I didn't. Okay. I'm gonna do a point on this. We're gonna dimension it to the center. I'm gonna go with 13 because I would bet dollars to donuts. Dang. Oh, what the hell am I can just measure it at its biggest point, Grant. You're just a moron. Come on, my dude. Call it 24. Measure from here to here. It's gonna over constrain it for right now. That's okay, because we're gonna delete this. No, damn it. I'm showing like 23.78. Just taking some more measurements, guys. I apologize for it here. Probably 23.75 seems like the right answer. That just seems too much. It's also because this isn't a constant curve, is it? No, it definitely is. Nah, it's 23. I'm gonna call it 23. Alright, we're gonna call it 23. I'm gonna call that. We're gonna end up making this thing a little bit bigger than it needs to be. But the trick is, we're doing that so we can measure where the freaking USB-C port is. Because on these Osmos, the USB-C port is not in the middle. It's in the middle, left and right, but top down it is not. So I'm gonna go to GrabCAD real quick. I'm gonna see if I can pull a USB-C model. Give me just a second. USB-C, USB-C. Wow, that did not take long at all. I got the step model for a USB-C port. It's more than I need. So I'm actually going to make a new folder. I'm going to save this because it's going to require me to save it. Save it as ammo can. We're going to upload that. Okay, sorry, just waiting for it to upload. And responding to all the things about my staff. Alright, let me go back to the stream, see what's going on.
Tell me I can count on you. Promise me you'll get me through. Just tell me I can do this too. For everything we fought to never.
Alright, come on. How long is this gonna take? Gosh, I just need a freaking USB-C port here. Like, come on, guys. Well, I guess I'll do a sponsored plug while we're at it. Thank you guys so much for watching. This stream is sponsored by 3D Musketeers, as all of them have been. If you would like to change that, because you definitely have the ability, you can reach out to us at YouTube at 3dmusketeers.com. But we help you take your ideas out of your head and into your hands with full art-to-part rapid prototyping and product development, utilizing cool technology like 3D printing and CAD. I am not a CAD designer. We've been over this before. I'm not a CAD designer. I just kind of try. So I appreciate you guys hanging out with me. We got our part. Let's insert into... Can I not insert into current... What? I want to insert this into what I'm working on. I wonder if I have to finish the sketch. Yep, there. Let's finish the sketch. Cool potatoes. Because I'm going to be persnickety, I am just going to flip this thing over. Because ultimately, that's how it sits in the Osmo. Going to move it back a little bit. Move it up. Because we do want it flush. And that's fine. What we need to do is we need to measure, so we need to get a dimension from here to here. So that's 1.42 millimeters. And so we're going to grab from that edge. So got my Osmo here. It's 4 millimeters. So we got to come in here. We got to click M for move. You know what? I'm going to align it first, because the align will get me kind of where I need to be. Oh, it's in multiple pieces. Rip. Alright, so... alright, we're going to align the entire thing to... here. Is that going to work? No, definitely didn't work. Well, I know it's 1.42 millimeters, so screw it. We're going to move the entire... I'm going to move the components of this in this direction, so it's Z of 1.42. Okay, because apparently I didn't just select the whole damn thing. I want the whole dang thing. Z of 1.42. Oh, okay, well now you're not... God, I hate this sometimes. Alright, Y of 1.42 now. Okay, so that gets me on the edge. Okay, we're going to do another move. We're going to grab the same component, and we're going to move it back 1, 2, 3, 4 millimeters, and that is where it stands on the Osmo. So, we're actually going to take this, and we're going to move it back to here. That puts our sketch, because I need to know where this is. I'm going to project basically all of these lines, because they are very, very important to understand where the USB-C connector is going to land. Because remember, we're going to be doing some custom circuit board work, okay? And hilariously, it might be a connector that looks just like this, but it's going to be the male side and not the female side. Do I have it all? Let's turn it off and verify. Beautiful, I definitely do. Alright, so we can effectively turn that off. We know that this is our USB-C connector. Cool beans. We are just gonna do just an extrude. Okay. Dang it. Why? Why? Why are you not going to let me... Is this not a... It's not a solid body. Dang. Alright, I gotta project some more. Give me a minute. This is not what I wanted to do, because it's going to give me way more lines than I need. But it appears this is the only way I'm going to get something that I can extrude around. Alrighty. We'll finish the sketch. We'll hide the component. Okay, now we can extrude. Now we're going to extrude. Really? Alright, fine. Whatever. We will extrude this up. I don't know. 12.7, half an inch. How is this one body? Oh, I see what you're doing there. Gotcha. Alright, I gotta go back and fix the sketch. Yep. Oh, because they don't actually connect. Hilarious. Alright, I'm gonna do a line between here and here, and here and here. Okay. Now, when we come back, I can uncheck this and that. It's like this and like that and like this and Alright, so we have our Osmo, we have our USB-C charging hole, we have our ammo can. Now we have to, and effectively the Osmo does kind of squeak out on either side. This I'm gonna deal with later because all we're doing right now is dealing with the bases. So let's get this thing kind of in place. So we want to modify a line. Oh geez, I'll turn on my analysis to make life a little bit easier. We're gonna go from here to there. Hello? Hello? Okay. So, alright, I'm just gonna choose from here to there. Why are you not letting me do that? Every friggin' time, my dude. I swear. Modify. A line. From here. I want to go to there. I want... Why are you not... Ah, jeez Louise. Alright, I'm just gonna hit move. We're gonna move bodies. Oh, maybe that's why. Let me go back and do an aligned, but instead of components, it's bodies. Yep, okay, that's what it was, because they're in a together component. Okay. Cool. Finally. If we do that move... Okay. Alright, let's turn off our analysis. We want... So this is the ammo box. This is Osmo blank. It's our Osmo blank base. So now all we need to do is just kind of get them aligned where we want them. So I'm going to hit the M key. So I probably want them to all go like that. So let's do that. Okay. Oh, faces. No, we want bodies. Do it from there. Rotate just like that. My hope is that we can basically fit like 2 or 3 of them. Yeah, that's fine. So we'll do that. we need to do a sketch. I need to do a sketch on this. We're gonna project that. I need to get my lines drawn in here. Okay. We have a good mirror line now as well, so if we wanted to mirror this, we can. I want to make sure that we are like an even distance, like 10.582 and 8.914. So what we need to do is we need to... I wonder if there's a way to move... Huh. Interesting. Let's go move. I want to move a body. I'm going to choose this body. I want to center it. I guess it doesn't need to be centered, but it would be nice if we could. The trick would have been is to design it. Jeez, Mother Nature. That was loud. I don't know if you guys heard that on the stream, but there's not a lot of you on the stream, so there's that. Okay, let's just keep rolling here. We've got that. I want to give it some space, I think, from the edge, so let's spring it, something like that. Honestly, that's pretty good. I'm really not concerned there. What I need to do is figure out my distance between this space and that line. 9.817. So I want to move it 0.183. We'll get it to where I need to go. Okay, so I want to move this down that way. Negative 0.183. And that should get me exactly 10 millimeters from this edge, which is what I'm going for. Beautiful. All right, and so that's why we can then do another line with an X. Oh. Right, we need to do it in this sketch. So we're going to do... no, this sketch needs to be over here. We are going to do an L with an X, come down from here. Right. We need to utilize the distance. Distance from here. Actually, we can project. Yeah, let's project this. Okay. We're going to do a distance from here to here. Oh, God, it's going to do that. All right, let me put a point. Create point. There. All right, so now we can do a distance between here and here. We want that to be 10. Okay. Got it. It might be a little bit closer to the edge. That's okay. Just kind of looking at the Osmo. It really doesn't stick out all that much. Yeah, like 5 millimeters. So if we have 10 all the way around, we'll be fine. And of course, the draft angle toward the top is going to make life a little bit easier. Now, the reason that I'm doing this is so that we can project, or so that we can pattern these out. So we're actually going to create a pattern, and a rectangular pattern. We're going to do bodies. No, we need to just mirror things. Sorry. We're going to mirror on the wall. We're going to mirror a body. Mirror plane. Dang it. All right. 1 second. I got to construct a plane through 2 edges, which would be here and here. Oh, nope. Oh, right. This is the center rectangle. We don't even need that. We can do a mirror. Gonna mirror the body. This body. Mirror plane. That. Because that's how you do them. Alright, so now we're gonna create a rectangular pattern. Rectangular pattern. We're gonna be using bodies, these 2 bodies. We're going to do a direction, which is going to be this direction. Now, we want to do, instead of distance, we want spacing of 20, I think. Apparently not. I want more than that. Where's it measuring distance from? Dang. So I'm trying to get it to be 10 millimeters from there to there. Let's see. If anyone knows how to do this, let me know in those comments. We are still trying to figure out, I guess. We'll just do that because I can come back and adjust it. But we want to measure from here to there. It's 22. So we got to reduce the 45 down to 43. And viably, that's right. Now that is 8 Osmos in an ammo can. That gives us 20 millimeters in between them, which is plenty of space for us to work with. Beautiful. Beautiful, beautiful, beautiful. All right. And it still gives us some space here, which is really, really nice. I wonder, could I also pattern out? No. I want to pattern this out, but oh well. So now if we look between this and that. What? Minimum distance? 202.1. That is not right. And here and here. 10 millimeters. Exactly what I wanted. Cool. So if we go back into this sketch and we look at a rectangular pattern, I'm actually going to select this. Is it 75 that works? Oh, I want spacing. Spacing, I think, needs to be... I think it needs to be 43. I think that's right. So let's finish the sketch and see what it looks like. So if we look between this marker and this edge, 10 millimeters. Yep, 43 millimeters. So a bit of an odd number, but that is a-okay with me. It just has to do with this, you know, that little extra bump. Cool. So now I have more reference lines and numbers that we can work with. By the way, if you're hanging out with us, make sure you come back at 2 p.m. We are going to be doing a premiere of the Ender 3 V2 review, which is kind of crazy. Let me see what's going on. All right. We've got that. Let's see. I'm trying to think of, like... I guess we gotta build a base now. Let's do it. So, we're gonna end up... let's see. Whoops. I wanna go back and name my sketches so I know what they are. Right, this is the, that's the Osmo base. This is That's the Osmo base in the can. This is the can bottom. It's the can top. Beautiful. It's gonna give me lots of good room in here. You will not. What? You're not, Nadav, you're not gonna watch our premiere on the Ender 3v2? I mean, you don't have to, but we would appreciate it. I feel like we work kind of hard on these. It'd be nice if, you know, being supported for the work that we do. It's all right. All right, let's keep moving on this. We got those. How do I want to make this base? I feel like it needs to be a new sketch. It definitely needs to be a new sketch. I am, however, going to turn off the old Osmo base. I'm going to project a lot of things here. We're going to project that. Going to project all of these. We turn off our bodies. We got everything that we need there. Gorgeous. Gorgeous, gorgeous, gorgeous. Okay. Let's turn all those off and let's start doing offsets because we need to start offsetting everything. And yes, I could have done this before I did all the patterning, and I probably should. But I'm not going to. No, I really should. Oh, why are you a construction line? What the? Your actual way of selecting things is broken again, Fusion. Dang it. Fusion, sometimes, like Autodesk, stop changing things. Seriously. I'm about to move over to FreeCAD. Like, I am really about to move over to FreeCAD. Alright, well, we know it's 43, so we can go ahead and do our pattern. Oop. We were so close to it being just perfect. Yeah, it's so weird. I want to do features. What? No. Get back into here. I want to do a pattern. Rectangular pattern of all of this stuff. Alright, we're gonna go... I don't know what it looks like there. That looks fine. We're going to do spacing. Yep. So distance is going to be 43. And we're going to go to 4. Sounds about right. Now if we go between here and here, 11.582 and 9. Okay, so that was not right. I'm gonna come back here. Then we'll just mirror these over. But I did it again. I should not have done that yet. Let me just do the offset, I guess. Jeez. 1 millimeter offset should give it enough worth of space. So actually a 0.5 millimeter should be more than enough. So we'll do that. So we got to come back to our thing here. I'm going to also grab all of that. Beautiful. Then we are going to do a mirror. We have all of this stuff. I do not like this new mechanic. I do not like it. Sam, I am. I do not like this new mechanic at all. Because, like, when you're doing small stuff like this, you're going to easily miss things, and you're going to hate yourself when you have to go all the way back and find it. I liked when I was able to drag boxes around things. Dang it, Fusion. Why do you do this? Mirror line. There. Oop. I want to select that line too. Cool. Careful. There we go. Yeah, it's gonna throw everything off. Okay. So we can delete that. That's fine. We can delete that. That's also fine. We can delete that sketch. What was this? What was this? Just a position. Don't know what you are, so we're just gonna delete you. Alrighty. So we have that now. Why can't I see anything anymore? Where are my bodies? Oh, Grant, you ding-dong, you had them turned off. Sometimes, man, sometimes even my own stupidity baffles me. Alright, so we've got our Osmo bases here. I can get rid of the blank base because we don't need it anymore. We're going to do an extrude command. We're going to take all of this up. 6. 10 at least. Let's take a look at this USB-C connector. Did it move with everything? No, it didn't. Okay. Let's see. Beautiful. Now what we need to do is we need to work on the bottoms. The bottoms are where we're going to have circuit boards, which I guess we can still figure out with this. Our circuit boards need to have the USB-C connector on them and then places for wires. Now, I don't have the circuit boards designed out yet. We're going to do that in an upcoming stream, which might be next week if I can learn how to do circuits fast enough. If I can't, then it might be the stream after. Let's see here. We need to get the center of this. And all of this needs to occur back before the pattern, which is thankfully right there. Alright, this is my real one here. So L and X. This is the true center of the Osmo. And we want to do a rectangle. I'm going to do a center rectangle right here at the center. We probably want these boards to be a little bit bigger than the Osmos themselves, I would guess. And I'd like them to be square, so we could do 30 millimeters square, right? No. Okay, so let's do 35. Because the Osmos themselves aren't square, but we need to leave enough room to add in, like, screws and all that kind of thing. So we're going to do an offset, again, on this. I'm going to do it in the other direction. 1 millimeter should be fine. We are getting disastrously close. Dang. Alright, we're going to do a rectangular board. Maybe 32. Yeah, 32 is fine. Because, yeah, anyways. The wires will all come out of here. They'll go into a central bus, which I might make a custom circuit board to go in the middle where all they have to do is go into one circuit board. That way it just kind of frees up some wires. Sorry, my back is spasming. Oh, man. Oh, cannot recommend. Cannot recommend, ladies and gentlemen. Not great. Not great. Oh, pain sucks. Chronic pain is terrible. And for all of you out there that are dealing with chronic pain, I feel you. I feel you. For better or worse. I feel you. Okay. Not a lot of people hanging out on the stream. I'm sorry, guys. I didn't realize I was that boring. I figured we'd have more people than 2. That's okay. I still need to get these done, so it gives me a good time to get them done. Okay, we have those. That's where our board's gonna go. This is our interior board. I'm gonna give myself a little bit of wiggle room on the circuit boards themselves, because ultimately everything may not line up perfectly. So we have to make it tall enough the Osmos can fit in. The circuit board goes into the Osmo. We can flip everything upside down, and then we can probably just epoxy the circuit boards in place. So that's something. Why don't we just do one large PCB, because it will cost me a lot more money than doing some small PCBs. We could, though. I don't know, Justin. We could. I'd be open to looking at doing one large PCB. That just seems like a waste of a PCB, because like if you look from here to here, it's 172 millimeters. But each of these being like 30, we could show how you make them with the crack, so you can break it all apart. I don't know. It might be cool. Maybe we do both and we see which one works best. That's really easy for us to do. I don't mind having 2 ammo cans for the system. I don't mind. It's fine. Ammo cans are cheap. These PCBs are not going to cost a ton of money. I want to do some circles, and I want to do them on the things. I would like them to be like 3 millimeters. That way we can use, if we're using screws, we can use M3 hardware. Yes, doing it so you can break the boards apart does count as one PCB. Look, we'll figure it out. I don't really know yet how I want to do it. I haven't decided, but I think it's mainly because I just don't know, right? I just don't know. Oh, I want to get rid of that constraint. So let's do another dimension from here to here. 3. All right, I want them all to be 3, so we'll do L, X, 1 there. Another one that goes here. Mirror this across that line. I want that center point too. Gonna do another mirror. I don't know, Justin. I'm kind of open to doing it either way. I don't care. Ooh, that's a little close. Whatever. Let's cut these back down to 2 then. Only gives you like a 0.5 millimeter for a 3 millimeter bolt. So yeah, no, these got to be 3. All right, what's my distance between here and here? Oof, not even a millimeter. Okay, maybe these circuit boards need to be a little bit bigger. Or I go to M2. We could go to M2. I don't know. We're going to leave that the way it is for now. I can always come back and change it. So we've got that. Let me go back into the sketch because there is more things that I need to do here. Where are my other patterns? This is why I don't like doing patterns this way. I'll just do another one. It is what it is. Alright, create rectangular pattern. Wait, why am I doing this? No, I'm gonna do it at the face level. I don't know why I did all this. I should do one and then you do all of your copies when you're done with it. Finish the damn sketch, Grant. Jeez. All right, we're gonna do an extrude here of all of this. The thickness of a normal PCB is something like 3 millimeters, so we're gonna dig in 3. It's probably fine. Question mark. Do I have a regular PCB laying around? Do I really not have any PCBs around me? Dang. Alright, I'm gonna assume it's 3. Maybe it's 2. Nah, it's 2. Alright, 2 millimeters it is. I do want to dig these holes in a little bit more. We're not ready for that. The holes there, that's just the holes for the board. Okay. Now... Oh, do you need thickness? We decide. I do want thickness because I'm going to put a bottom plate on everything. Which actually means that is the bottom. Did I do something wrong again? You know, it would have been cool if I went all the way out to the edge, but... Huh. I don't know how to fix that. I don't know how to fix that. Damn. Would have been cool if I went out to the edge and made it so it fit in perfectly. This is going to need some more tinkering. I'm going to tinker with it a little bit off a stream so I can get that all to line up the way that I want. I'm not going to bother fumbling with it on stream. My hope is to get a lot of, like, the main work done on the stream so that you guys can kind of watch this process, because this is going to be a main channel video of us building this entire setup. So you're going to see the, you know, this initial design, which will be probably a speed art thing. I don't know how we're going to do it, but we're going to do it. It'll be maybe a speed art thing, and then I'll have videos from one of our other sets of me doing all the wiring, the soldering. We'll do all the testing with the cameras, and yeah, all that fun stuff. I don't know. I've seen other creators do this, and I just thought it would be fun for us to do it too. You guys will have to tell me if you enjoy this kind of thing. If you do, please let me know in those comments. I am in a lot of pain right now, and I don't know if I'm going to be able to focus a whole lot more. I'm going to try, but instead of going to sleep, which is normally what happens with my leg, I'm getting a lot of bad leg pain, and it's shooting up into my back, causing a back spasm, like a back muscle spasm. So forgive me, I might be ending this a little bit early, but if you are watching this, please make sure to take a look at our video coming out at 2 p.m. Eastern time, of course. We actually bought an Ender 3 V2, and I reviewed it. Yeah, you'll have to see for yourselves. I'm really proud of that video. I think our editor did a great job on it. I spent 4 hours filming the video, and we ended up splitting it into 2 pieces. Don't worry, the first piece is like 13 minutes. I promise it's not that bad. But the second piece is going to be all about the unboxing and assembly of it. We didn't want to put it into one video because, my god, the assembly took me like an hour. It took me less time to assemble a Prusa Mini than it did an Ender 3 V2. Now, it's probably because I did things out of order, but I didn't immediately understand that I was doing things out of order until well close to the end of it. But I need to split this because thinking about this, excuse me. I need to split this because I want it to have a flat bottom. I don't want the circuit board to be the bottom. So I want the bottom to encapsulate that circuit board and hold it in place. Now the trick is... Oh, damn. Did I screw this up? I guess not. So I can cheat because I haven't figured out my edges yet, which I do want to figure out. I can cheat by just making it come down a little bit, raising everything up. I could do that. I don't know. I don't know. See, this is the problem when you're designing things live without a ton of actual planning. Like, I know what I want to do intrinsically, but it's always, and see, I know I'm not the only one that struggles with this. Like, in my head, I just want to cut it, and I want to basically hide the circuit board inside the 3D print. Now, it's going to be a 2-piece print. It'll be bonded together. The circuit board will live inside of it forever. But I guess we could just do it this way. It's not that big of a deal. I will put... you know, this way's probably... It's just going to be easier. This way's going to be easier. It won't look as cool, but... I mean, I guess I'm not too worried about that. But it would be cool if we had, like, a central bus line that all these could be wired to. You know, so you just come out, come out, come out, come out, and just had, like, a central line of... of connectors, so I had a 2-pin, 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 2-pin. So all I would have to do is come out with all my charge ports. That would be pretty cool. Be even cooler if we could do it. See, I wish the Osmos could give clean signal through the USB port, because then I would have the entire USB port come out, and then I could have an 8-camera array recording at once, which is kind of terrifying, and I don't want to do it. But alright, I think I'm gonna call it here. I'm in a lot of pain, guys. I'm sorry. At 2 p.m., we're gonna be doing a premiere, so YouTube premiere, so you all will be able to hang out with me and as we make some cool stuff here. So anyways, guys, I will see you all in the next one. Next week, we're gonna continue this project. I might work on it a little bit, but I will probably show that work that I did on stream first. Because I want to bring you all along on this project as we get it done. Because I think this is a cool maker project. It's going to involve custom electronics. It's going to involve soldering. It's going to involve, of course, a lot of 3D printing. And ultimately, it's going to benefit our shop because it's going to make these things more usable. And if you have a DJI Osmo Pocket and you want to make a charging case for it, let me know. We will probably not be open sourcing this, because I think the goal for us will be to sell these to other content creators and other people that use these cameras as their daily shooters, because I think for the money, they're a pretty tough camera to beat. However, if you hang out on all of these streams, you will probably be able to reverse engineer it yourself. So there you go. It's going to be a thing. But 3DM, we want to work on building a kind of a repertoire and a base of products that we've built ourselves that we want to sell out there to the public. Maybe we'll open source it for people that want to build it themselves. Maybe we'll keep it closed source. There's nothing really all that closed sourcey about this. Maybe we'll just open source the whole dang thing. But the goal is, if you want to do something similar, you'll be able to. It's fully parametric, so you can have 2, 4, 6, 8, and it appears that you would be able to fit 10. And even less if you went with shorter spacing between the cameras. If you turn them sideways, you could probably go 3 wide. I want them like this because I am persnickety. I think it will look the best. Anyways, guys, I hope you all enjoyed this one. I know it was a little bit of an odd one. I apologize, we're not able. We were supposed to run all the way till 2. Not today. I'm in too much pain, so I will see you all in the next one. Don't forget to call your loved ones. And as always, keep making awesome. Stay safe out there. Seriously, this world, man, stay safe out there, guys. Call your loved ones. When was the last time you called your loved ones? Call them. We'll see you in the next one. Take care.